Hello. Today I'll be doing my final reflection on the work I did for my final project. I did my project on a subset of UFO sightings around the world. The original data set was a collection of over 80,000 sightings from 1949 to 2013. In the interest of the class, I chose to take a subset of the original data of sightings that occurred between 1979 to 2013. I also decided to further limit my data to only the sightings recorded in the United States, as my chosen data set only had a handful of sightings in the other countries. The original data set had information on the time. Let me see if I can show you. On the time, the location, which includes the country, the city, and the province or state of the sighting where it was applicable. It also had the description of the event according to the eyewitnesses, the shape of the UFO, the length of the sightings or encounter, as well as the longitude and the latitude of the event. It also had the described length of the encounter, pre-standardized version in seconds, as well as the date of that the sighting was documented. These were the only two columns that I ended up not using in the final visualization. So we can go to the final visualization now. Okay, and I'll see if I can minimize this. So the final visualization can be accessed in this website. From here, as was shown before, the audio plays to set the mood of the visualization. In the final visualization, the user can zoom in and zoom out of the map. The user can also hover over the plot where the and hovering will show the user where the sighting was located, eyewitness descriptions. Maybe I'll find one here. Better one. Eyewitness descriptions of the event, the UFO shape, as well as the time and date of the sighting. I have to quickly switch to Chrome here, as I think there was a little bit of issues with using this on Edge. But as I was saying, clicking on a plot isolates the data and dims the rest of the map. It gives the user the option to keep or exclude, as well as do the details that's listed here in a different page. And you can see it here. Keep only. There you go. Zooming out will show you that it's the only one. And then exclude will take it out of the final map here. The user can also highlight the sightings in a state by interacting with this filter. As an example, we can highlight sightings in California, and when you close it out, it returns back to its resting state. The user can also toggle the year slider here to show the different sightings in specific years. As you can see, interacting with the legend, the user can also click on a specific UFO shape, and the instances of this particular shape will be highlighted in the original map. Working with the data set, I did notice some really kind of notable trends in the way these sightings are recorded. And so I thought it was imperative to add this UFO sighting trend filled in line graph in the lower right hand side to really show this interesting spike after a certain time. So as you see, when you hover through the filled in line graph, you will be able to see the year and the number of sightings that were recorded in that year. And so this spike in particular is really the trend that prompted me to add this little tidbit here for the user. The user can also search a particular city in the United States. We can, let's look for something here. Port St. Lucie. Oh, sorry. And it will zoom into that particular city. Go back. The user can, as I've said, zoom in and out, manipulate their view, and then always take it back to the resting state, which is this home button. The user can also kind of choose plots, as you can see here. As for my single data column, I'm choosing to highlight the UFO shape column of my data. This includes the 20 different UFO shapes reported by hundreds of witnesses between the years of 1979 and 2013 in the United States. I ended up using alien heads in a spectrum of green, reminiscent to aliens to keep the theme. I had initially had this column represented by 20 different UFO themes, theme shapes, but found it cluttered and hard to discern each shape, so I decided against it and found this cleaner solution instead. I also had to clean up some of the data, as none of the data in this column followed any semantics. Some were lower caps, some were all caps, some were capitalized, and some were not. And so I decided to uniformly all caps the data, as you can see. I kept Tufts' guide in mind as I developed the final visualization. I tried to maximize the data ink and aimed to keep the viz easy to read, as easy to read as possible. I think I also achieved maximizing the data density, as it is easily distinguishable even from afar. This was also the guide that pushed me to just keep on the alien head direction. I think I have minimal to no chart junk, and have multifunctioning graphics. I tried to keep all aspects of the visualization as easily distinguishable as I can. I kept a familiar map depiction, and plot points that easily bring aliens and UFOs to mind. I was also conscious of the color themes I chose, making sure I'm sticking to and not straying too far away from the theme of the visualization. I tried to implement parallelism with the alien heads and opted against a 3D map depiction, as I did not end up liking the way it looked. It was just not as clean, and it didn't really add much to the final visualization. I also think I used the space in the visualization well. I initially did not want to enable zooming to and away from the United States, but opted to put it in as it allowed the user to manipulate their view, especially the plots that would end up behind the filled-in graph when I implemented the automatic zoom in the area. Before something like this would happen in the automatic zoom, or something along this line where the data would be hidden behind the line graph, and so I needed to give my user the ability to kind of manipulate the visualization to see these plots. But yeah, I initially didn't want to allow the user to zoom in and out, as I didn't want them wandering outside of the United States, since there was no data outside the United States, as you can see. And since there was no data, it kind of looked a bit odd to me. But as I was saying, I encountered that issue in implementation after I added the line graph. I really like how my final visualization turned out. I think it's fun, easy to interact with, and intuitive. Through going back and forth with my buddy Bobby, we both decided that the data looked more compelling if I filtered my data subsets to the United States. He also helped me pick out the final shape I ended up going with. I had about 6 different versions that he helped me pick through, and I think we picked the best one. I had ones with UFO shapes, which in theory would be something that you would see here, but it ended up looking, I don't know, like I think it was just the shape of the specific shape, and I tried a bunch of other UFO shapes and they had similar issues where it almost like all blended in to each other, and it's kind of hard to discern each plot line, as opposed to what you can see here. I mean, even without hovering over it, you can kind of clearly see these heads in the visualization. I also thought that the class feedback from the smaller incremental demos was very useful to me, as it gave me an insight of how a larger group of users would react to my visualization. I do think that if I had the opportunity to do this again, I'd try to find a way to disable the user from freely zooming in and out of the country, but show the full extent of the visualization while keeping this kind of line graph that I ended up having to work around, because I think it's really important to kind of to have the user easily see this really dramatic trend in the data. Yeah, I just think it would make the viz all the more better to look at and interact with. And that is my final visualization. Thank you for listening. Thank you.